Yeah, very good morning to one and all. We were over here on the third day of the AICTE Training and Learning Academy sponsored SPARSE Signal Processing and its Applications Faculty Development Program, organized by Department of Electronics and Communication Engineering, National Institute of Technology, Andhra Pradesh. So this is the third day and the seventh session is going to start now. And in this session, we are going to have the topic of the session, the theme of the session, signal processing applications and machine learning. And the session goes from 900 hours, 900 hours to 1100 hours, almost 2 hours session will be there. And the speaker for today's session is Professor T. Kishore Kumar of NIT Varanasi. So I'll be giving a brief introduction of Professor T. Kishore Kumar in the short span of time, and then I'll hand over the session to Professor T. Kishore Kumar sir. Professor T. Kishore Kumar sir is currently working as a professor in the Department of Electronics and Communication Engineering at National Institute of Technology, Warangal. Earlier, he was a former visiting professor at Asian Institute of Technology, Bangkok, and he was deputed by Ministry of Human Resources and Development, the present Ministry of Education, Government of India. Very recently, he visited Asian Institute of Technology as a visiting professor. And formerly, he was the head of the Department of ECE, and he is also the head of the Institute Computer Center at NIT Warangal. He's associated, coming to his experience, he started his, from 1999, he was associated with NIT Warangal in the position of assistant professor, associate professor, and then now the professor. Prior to this, he worked as a technical officer in Cabinet Secretary, Prime Minister Office, Government of India. He is a member for Central Council Board, CCB, AICTE during 2009 and 10, and a member of Electronics and ICT Academy, National Institute of Technology during 2015 to 2017. Presently, he is a member of Andhra Pradesh State Council of Higher Education, APSCHE. Coming to the awards and recognitions of Professor T. Kishore Kumar, he was awarded Best Engineering Research Award 2017 from NIT Warangal and NIT Warangal Alumni Association in recognition of his outstanding research, consultancy and training in the field of electronics and communication engineering. He was also awarded Research Excellence Award 2017 by Institute for Exploring Advances in Engineering. R&D contribution. Dr. T. Kishore Kumar sir has completed 2 DRDO projects worth 18 lakhs, 1 MHRD NMECT pedagogy project worth 7 lakhs and 1 SCRB project worth 18.57 lakhs. Fortunately, I am one of the co-PI of this NMEICT project, pedagogy project. In addition, the project which I just recently completed, for that also Professor T. Kishore Kumar is the co-PI, and it is worth of 25 lakhs. Currently, there are 3 major ongoing research projects sponsored by SCRB with a worth of 1 crore. So 3 projects are running under Professor T. Kishore Kumar sir at present. So coming to the supervision and publications, under his amiable guidance, 9 scholars have been awarded PhDs and 1 scholar has submitted PhD synopsis. And I am very fortunate and I am very thankful to Professor T. Kishore Kumar that I am the very first scholar of Professor T. Kishore Kumar who got awarded the PhD degree under his supervision. So I am the very first scholar and I got a complete support from sir throughout my PhD tenure over there at NIT Warangal. So at present 4 PhDs are working under his guidance. He has also guided over 26 MTech students and 30 BTech students. He has published more than 34 international journals and 37 international conferences all across the world. And one important point I would like to stress over here, total 9 PhD scholars he awarded the degrees at NIT Warangal Department of ECE, and he is the only professor who awarded more PhD scholars, who awarded more PhD degrees from the department, of different for different students. His research expertise includes speech signal processing, adaptive signal processing, machine learning, radar signal processing, real-time signal processing using embedded systems, advanced digital system design, real-time embedded systems. Sir, we are very fortunate to have you over here. Unfortunately, this FTP is being conducted online. Otherwise, you would have been given a token of appreciation. Otherwise, please accept this small invitation. I hand over this session to you, sir. We were very thankful to you for accepting the invitation and joining as an expert speaker for this smart signal processing and its applications faculty development program sponsored by ATAL Academy and is being conducted by Department of DC NIT Andhra Pradesh. Thank you so much, sir. Over to you, sir.
So good morning, everybody. Is my voice is audible?
Yes, sir. It is audible, sir.
No, for you, okay. For participants.
Yes, sir.
Yeah. So first of all, I'd like to thank the coordinator, Dr. Kishore Kumar. So in fact, he is my first PhD scholar who has completed successfully, very dedicated and honest professor. And I would like to thank Professor C.S.P. Rao sir, Director, NIT and present head of the department, Dr. Kiran Kumar, and other colleagues in the NIT EC department. In fact, when NIT Warangal is the mentor institute for NIT AP, so and in fact the in charge HOD at the time of beginning days for NIT Andhra Pradesh. So I have a privilege to visit that particular institute, and in fact under head of the department of KISHORE, I think I visited as a guest in association, that Electronics Association, NIT Andhra Pradesh. So with these few the remarks, so now I will try to start the session. So today this session I will try to divide into three parts. The first part is, of course, everybody is familiar with signal processing. Since this particular topic is signal processing and applications and machine learning, so what I will do is I will try to focus the few minutes about the very basics about signal processing, which everybody have an idea about the signal processing. Then I will try to focus on applications of the signal processing. Then my second part is I will try to concentrate on machine learning, artificial intelligence, and the deep learning, about the basic introduction about these particular topics. And my third session is about the some of the applications of these particular machine learning applications, how we can come across in this particular domain. Of course, your topic is a sparse signal processing, but definitely I have a hope that these particular topics, which will definitely useful in your sparse signal processing or whatever the program which we are attending. So thank you once again. This particular the session, because since all are faculty members, and it would be rather the listening mode, but it should be one-to-one interaction mode. If it is there, then that will be better. Okay, so I will try to share my PPT, so you can tell me whether it is visible or not.
It's visible, sir.
Okay. So basically, a signal, I think you have an idea. It is formally defined as a function of one or more variables, which conveys certain information on the nature of physical phenomena. So I think everybody have an idea about different examples of signals. Speech signal is one type of a signal which conveys certain information. Then ECG signal. Then we have a radar signal. I think you have a topic about radar signal processing, where we can transmit a particular pulse and we can receive that particular pulse, and we can find out the range and direction of a particular target with the help of a radar signal. So that means it is conveying some particular information about the target position, the range, as well as the direction. Okay. Hello. Madam, yes, madam. I am in class, madam. Can you tell me, madam? Miguel and Leo. In fact, it is over, madam. Because of Dasara vacation, I could not send it. So most probably tomorrow you will receive, madam. Yeah, yeah, yeah. Tomorrow you will get it. Yeah. Okay. So sorry for the disturbance. There is some call I got. Just I will keep silent. 1 minute. So these are the different the examples about signal. As I told you, the radar signal which conveys the information about the target position range. Okay, similarly we have a two-dimensional signal, sinusoidal signal. So all these particular signals are the examples are for the signal. And coming to the different types of classification of signals: continuous time, discrete time, periodic, non-periodic, causal, non-causal, even and odd signal, deterministic and random signal. So here, the other top signals are actually the various signals which we will have the familiarity. But this is the deterministic and random signal. Can anybody have an idea about deterministic and random signal where we can come across? What is deterministic signal? What is a random signal?
Sir, if we know the characteristics of the signal precisely, and if there is no ambiguity with respect to the signal behavior, we call
Okay,
it as deterministic, sir.
good, good.
If there is some ambiguity with respect to the characteristics, random means it doesn't mean that signal occurs randomly. It means that our knowledge about the signal is limited.
Yeah, so that means as a overall from your discussion, I can say that for deterministic signal there is a certainty is there, and for random signal there is no certainty. Is it right?
Exactly, sir.
Yeah. So your good name?
Sir, I am Isigarajan, sir.
Yeah, yeah, good. So like this, we have a different classification of signals. And olden days, people used to analyze the signal with the help of a time domain approach. Like I think, if you remember, the olden days, people used to call about the strip chart recorder, where we can. This is based on the permanent moving coil galvanometer, and where we can pass a current through that, and then we can record it, and then we can display, and then we can process. That means that is one type of analysis of signal. And as time passes, then we have a cathode ray oscilloscope. With the help of a cathode ray oscilloscope, we have the sinusoidal signal, where we can analyze the amplitude frequency of a particular signal and various parameters which we can determine with the help of cathode ray signal. And coming to the DSP applications, 80% of the DSP applications require some form of frequency domain processing rather than time domain processing. So the frequency domain has come into picture, and in the frequency domain, we can represent the signal in terms of its impulses. Okay, so then from that particular impulses, we can analyze a particular signal. Ultimately, you can say that the signal processing is the what we can say decomposition of the signal in terms of its the impulse components. So similarly, this term has arrived from the Fourier series analysis, where we can decompose the signal in terms of its Fourier components, such as sine and cosine terms. So you must remember that signal processing means decomposition of the signal in terms of its impulse coefficients. If it is either the time domain or the frequency domain component, we need to express that particular signal or decompose that particular signal in terms of its impulses. So this is the relationship. I'm not taking much time. And after the signal, we have a system. System means it's an entity that responds to a particular signal. So we have an input and there is a phenomena of a particular system, and we can get an output. So there are different types of examples like RC, then we have a camera, then we have a the speech recognition. Okay, so these are different types of systems where for giving a particular the input, we will expect some particular output. And there are certain examples like mass and spring tank, cell phone system. These are different types of examples of different types of systems. Okay, and a mobile, the cellular mobile communication, how we can transmit a particular the information and how it will receive the other end. Okay, so there are certain particular the phenomena that took place, and in order to receive that particular output, this is one example. And similarly, how we have a classification of signals, we have also have the classification of the systems. Okay, so continuous and discrete system, linear and non-linear system, time variant and time invariant system. Like that, we have a different classification of the systems we have. As I forgot one particular point, when we are discussing about deterministic and random signal. Okay, as you have seen that in the deterministic there is a certainty, and random signal there is no certainty that is presented. That's why we can go for, we can process the determined signals with the help of analog filters like the general specific low pass, high pass, band pass, band reject filters. But in the case of the random signal, it's not predictable. That's why we can go for the digital filters, where we can use the adaptive filters or different types of filters which we can use it. We can predict the nature of a particular signal according to the changes that took place for a particular signal. Okay, so how we have a classification of signal in the system, also we have different classification of the systems. And coming to the real world signal processing, we have a two parts. One is the analog domain, other one is the digital domain. Any particular signal, when you want to the process in the real world signal processing, we need to take the analog signal. So how we can take that particular analog signal with the help of the traditional methods, a tachometer or a different methods, we can retrieve that particular signal, and this particular analog signal which will convert into digital with the help of A to D conversion. There are different approaches are there in the analog to digital conversion, successive approximation method, dual trace approach. There are different approaches will be there. With the help of those particular approaches, we will convert into digital, and from the digital we can apply the DSP techniques, and from the DSP techniques we can process that. So there are two things that are there. One is analog to digital, another one is the digital to analog techniques which we can use and we can process, and at the end user the analog signal will come into picture. So this is actually the real world signal processing. In any particular application, we need to, what we need to do is we have to convert the analog signal into digital and applying the digital signal processing techniques, and then we can use it, and then again we can send it to for the analog domain for the practical purpose. So this is actually the technique which we can use it in the case of the real world signal processing. And why actually for what purpose we will use the signal processing? The picture itself shows the different the applications. And there are the two concepts that I want to discuss. One is the what are the different types of operations that we can apply in the case of a signal processing. So even when you deal with this sparse signal processing or whatever the different types of signal processing, there are certain basic operations that we can use it for signal processing. One is called the spectrum analysis, then the another one is the digitization or reconstruction, then compression, and third one is the storage, fourth one is the modulation, and the fifth one is the prediction. So these are the basic operations that people use in the case of this signal processing. And this signal processing is not only useful in one particular domain, but this will occur in computer networks also. I will try to show that. See here, I think you have some of the people, you have a familiarity with the OSI reference model. So why do you want to use the OSI reference model? Can anybody tell me? Why do you want to use the OSI reference model? Can anybody having idea?
The networking models are for translating the data to a network. So
Yeah.
Sir,
there is a two
transmitting
model like,
data from transmitting data from one computer to another computer, one
Okay.
network to other network.
So there are two approaches are there. One is called the 7 layer I told. Another one is there, the frequently used one.
FTP, I think. FTP, OSI, and
TCP IP approach.
I forgot.
Okay. Yeah. So in those things also, you can see that there are different types of layers. We have the physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. In the case of the presentation layer and in the case of the physical layer, we can use the signal processing concepts. The signal processing concepts such as analog to digital conversion, data compression, source coding, modulation, equalization, multiplexing. So all these things which we will use it in the case of the reference model also. So what I mean to say is this signal processing is not only restricted to one particular application, but in every aspect we can use this particular signal processing. Why do you want to use the signal processing? So I think most of the people, I think some people they have done PhD, some people they are doing the research, and some people are MTech, are so different domain people are there. So anybody who want to pursue PhD or who want to guide the PhD, okay. So from the signal processing, these are the fundamental the techniques that we need to use in every aspect. One is called the signal analysis. So in the case of the signal analysis, we can have the transitions, patterns, peaks, frequency distribution. So we can analyze the signal based on its transitions, based on the patterns, different types of patterns, based on the peak levels, because these particular peak levels, normally whether if you want to know in particular applications like speech signal or radar signal, or where we can come across, suppose in the speech signal, if the signal is a voiced or unvoiced signal, okay, we need to find out the autocorrelation, and from the autocorrelation, if the peak is there, then I can say that it is a periodic signal. If peak is not there, there is a distortion, there is a distortion is there, then I can say it is a noise. Like that we can analyze the signal with the help of these particular parameters. So in the case of the signal processing, the first the purpose why do you want to go for a signal processing is signal analysis. Everybody should remember who are present now, the first application, the first thing why do you want to go for signal processing is, the first thing is signal analysis, the second one is the signal decomposition. As I told you earlier, signal processing itself is nothing but the decomposition of the signal in terms of its impulses. So separating the messages or separating the message and noise. So here every signal which is corrupted with some particular noise. There are two types of noises which come across. One is exogenous noise, another one is the endogenous noise. So with the help of these particular we need to remove these particular noise, and we need to separate the message and the noise. So the major the application, the major purpose to go for signal processing is signal decomposition. First one is the signal analysis, second one is the signal decomposition, third one is the feature enhancement. So we need to calculate the features. As you see in your SPARSE, the signal processing also, you need to calculate, you need to select the features which are necessary. So that's why your concept has come into picture. Optimization, what you can say that dictionary optimization and dimensional reduction. So why do you want to go for the, while developing a dictionary, we need to reduce that particular, what you can say, declare that particular reduction in the dimensionality. The purpose is whichever the features which are specific only we need to separate. The other features which does not have the particular more information or which is correlated with the same information, we need to discard those particular things. In that particular case, we need to develop a particular dictionary which will give the significant features which are necessary for a particular purpose. So the feature, the determination, feature enhancement is very, very important. So certainly when you select that particular features, these particular features are weaker in section. So then we need to boost that particular signal components, and we need to sharpen that particular image. And then the fourth one is the noise reduction. Then we need to compress the signal. Noise reduction is the major domain. Okay, and the signal compression and the signal encryption and transformation. Okay, so these are the different types of purposes for going for the signal processing. Okay, so can anybody tell me that why do you want to go for the signal processing? And can you give me one simple one word example about these particular things, where we can come across, or anywhere the research domain where anybody have used these particular things? Those who answered, the same persons don't answer. The other persons, please don't think that whether it is correct or wrong. Okay, I will encourage that if you interact and if you express your feelings, that will be better. Okay, so my question is, first you tell me why do you want to go for this particular signal processing from this, and if you have come across, let us take from signal analysis. Yes, in my work I have taken the signal and I did analysis with the help of this particular parameter. Or signal composition I did, or feature enhancement I did, or noise reduction I did. Like that, in your area or in your domain, or if you made your students to work in the domain, you please share within 1 minute only. Don't take much time, but at least for each particular point, 1 minute if you are able to tell, I'll be happy.
Excuse me, sir.
Yeah, you
Sir,
introduce your name
sir,
and from which
sir,
place you have come.
sir. My name is Lokesh, sir. I am working under Kishore Kumar, sir.
Okay.
Kishore Kumar, sir. Sir, in signal analysis, I came across peaks, sir, spectral peaks, actually.
Okay.
So the peaks determine the signal direction at the angle which it came, at the angle which it came, uh,
Okay. Okay.
DOI estimation. I
Yeah, that
get
is
DOI
okay.
estimation.
But here, from this particular, the operations that I am showing, which particular concept you used? That is my question.
Signal analysis concepts. Signal
Yeah.
analysis.
Okay, good. Okay. Next.
Good morning, sir. I am Isekirajan, sir.
Yeah.
Sir, actually, we have used the signal decomposition. Actually, the signal decomposition, there are different types like frequency decomposition, time
Very
frequency
good.
decomposition, time scale
Okay.
decomposition. We have gone for time scale decomposition in our research work, sir. One of my research scholar who did
Yeah.
ultrasound despeckling, he has gone for wavelets and beyond wavelets, sir. Thank you, sir.
Okay. Good.
Hello, good
Next.
morning, sir.
Yeah. Yeah.
This is Sanjay from Bangalore.
Yeah.
Sir, I am working on signal compression using compressive sensing techniques, and I had used 1D and 2D signals as my input. And for 1D, like audio signals, I have used a feature. I'm working on the enhancement of audio or speech signals.
Yeah.
And whereas related to 2D signals, working on the signal compression part, sir.
Very good. Very good. From girls' side, no girls are there in this FDP. What, Kishore? It's only meant for gents.
No, it's not like that, sir. I request lady participants to please respond.
Okay, so if nobody is not there, okay. Okay, so like that, everybody, they how to use these particular signal processing concepts in their particular domains. So that's why these two are very, very important. One is the operations what we are using, and the second one is why do you want to go for signal processing. Without these two concepts, there is no research in signal processing. any particular tool or any particular the application part or any particular thing which we can use, but without using these particular terminology or without using these particular techniques, we can't proceed in the case of signal processing. So this is actually the basically how we can analyze a particular signal. From the analog filter, we have analog to digital converter. We'll use the DSP algorithm, and we have two types of approaches: time domain display and frequency content display. We can get. This is the example. We have a audio signal, and then there is a the spectrum which we can get on layman spectrum. Okay, so like this we can perform the particular the analysis of this particular signal. Okay, so this is one example about speech data. Okay, the speech signal, we lost the golden chain, and this is the spectrum, speech spectrum, how we can perform. So this is one example that I want to show, and this is the first signal processing, that is the radio detection and ranging radar. Okay, one of the first signal processing application. It was implemented in analog. Okay, and which encounters the lots of problem: aging, stability, sensitivity. Okay, and coming to the fields of signal processing, I will not take much time here, but there are different types of the fields of signal processing. One is the statistical signal processing, where we can analyze and extract the information from signals and noise based on their stochastic properties. That is called the statistical signal processing. The second one is the audio signal processing, where for electrical signals representing the sound, such as speech or music. మళ్ళీ చేయండి మా ఏమా for electrical signals representing the sound such as speech or music, that is audio signal processing. Then the third one is the speech signal processing, where we can process and interpret the spoken words. That is called, the third one is called the speech signal processing. This is the third domain. And fourth domain is the image processing. Okay, image processing in digital cameras, computers, and various imaging systems. We can use this particular signal processing, because all these things are everybody have the familiarity with these particular domains. That's why I am not putting much time on these particular cases. Then video processing, where we can interpreting the moving pictures. We can use this particular video processing. Then array processing, for processing the signals from array of sensors. We did one project with MTech, that is the processing the signals from array of sensors, where we kept the sensors.
Hello, sir. Hello. Participants, can you hear sir's voice?
No, sir.
Is my voice not audible?
Now okay, sir. Now okay, sir. Please continue, sir.
Okay, array processing, for processing the signals from array of sensors. So as I told you that keeping the sensors at the seashore, and we will try to retrieve the sound that is coming from other part of the seashore, and we can store that particular the sound, and this particular sound by using the acoustic processing, acoustic signal processing, we can convert that particular sound into signal, electrical signal, and from that electrical signal we can analyze the, what you can say, the information from that particular signals. So that is called the array processing. Then third one is the seismic signal processing, where we can find out the artifact from the seismic signal processing. Okay, like that, different fields of signal processing we can come across from the signal processing, and these are the other particular examples of DSP. And this is the specialty about DSP over that particular microcontroller. Of course, this is the different domain. Okay, and coming to the digital signal processing or manipulation of signals which are represented by sequence of numbers or symbols using digital techniques. Of course, this is the processing scheme: analog input, then we have analog filter, then analog to digital converter by using the DSP processor, and we can convert digital to analog, and we can reconstruct that particular signal, and we can get a analog output. These are the steps that everywhere people use to attempt for a digital signal processing. These are the basics in DSP. Coming to convolution, correlation, bilinear transform, discrete Fourier transform, Z transform. Okay, these are the things that people use: FFT, DFT, correlation. Of course, here with the help of the autocorrelation, cross correlation, we can use it for different types of applications. Okay, so cross spectral analysis, detection and recovery of signals buried in the noise, pattern matching, delay measurement. Okay, so these are the different types of filters, FIR, IR filters, and these are the different advances in DSP. We can use this signal processing for signal modeling, optimal filtering, spectral estimation, adaptive signal processing, multi-rate signal processing, speech processing. All these particular domains are each one which is having the different domain. Okay, so each one it will take another 2 hours time. So these are the advances. You please have a note about it. And these are the general applications of signal processing in engineering. Okay, so we can come across different
Sir,
types of.
excuse me, sir.
Yeah.
Sir, if time permits towards the end, what is
Yeah.
the fundamental difference between optimal and adaptive signal processing, sir? Adaptive means iterative in nature.
Yeah, 1 minute.
Optimal,
One
yes,
minute.
if
One
possible.
minute. Yeah, 1 minute. Now only I will tell. There are three things are there. One is called the optimum. Another one is called optimal. Okay,
Yes,
optimum,
sir.
optimum, optimal, and then what you asked is adaptive. Okay, so optimum means here it's both will give the which are synonyms only. Okay, so I will try to give an example. I will show that particular thing. So optimal filtering means here the examples for optimal filtering, which is called the Kalman filter, is the which is suitable for optimal filtering. I've heard about Kalman filter. Anybody heard about Kalman filter or Weiner filter?
Yes, sir.
Yes, sir. Wiener filter we can understand, sir, but Kalman filter very difficult to understand, sir.
Yeah, yeah, yeah. So 1 minute, I will try to show that.
Sorry, sir, if I have
No,
disturbed
no, no,
that
no,
flow.
no, no problem. Oh, no problem. Because I will try to show that thing. Because is it visible? Because there is no
Yes, sir, it is visible, sir.
yeah, there is no time. That's why I am not discussing adaptive signal processing. In fact, I asked Dr. Kishore or Pulikishore also, but he said, sir, directly signal processing and vision learning he go. Specifically, I asked adaptive also. I think already you have come across. So these are the filters. Why do you want to go for adaptive filters? Means you can see that this is the useful signal and this is the noise. Okay, so the case 2 is slowly the signal is occupied by this particular noise, and there is a case that comes across. Both are actually the worst case is the two frequency bands are overlap. Useful signal and noise are overlap. In such a case, we can go for the adaptive filter. Normal the analog filter cannot be used to filter out this particular the signal. So we need to predict the nature of the signal according to characteristic of that particular the signal noise. We need to adapt itself, and we need to process. In such case, see here, if there is a spectral overlap between the signal and noise, that means the interference spectrum and this is the desired signal. You can see that the desired signal spectrum is there, and interference spectrum is dominating this particular desired signal spectrum. So in such a case, we need to go for the adaptive filter. So conventional filters are used where the signal and noise occupy the fixed and separate frequency band. When the filter characteristics are to be variable and adapted to changing signal characteristics, the coefficients of the filter should vary and cannot be specified in advance. In such case, we can go for adaptive filter. So how will be the adaptive filter structure? There is a variable filter and we have an update algorithm. So this is the input, and we can filter out the signal, smoothen the signal with the help of the variable filter. Normally we will use the FIR filter, and we can get the estimated signal, and this estimated signal we can subtract with the desired signal, we can get some particular error. So as I told you that this error must be minimum, that is, you need to get the optimum. So in order to bring out this particular optimum, we will use different types of algorithms. What are the algorithms that we can use? One is, this is actually the another example about the adaptive filter, because it acts as a noise canceller. As I told you, signal with noise and digital filter adaptive algorithm. So this particular combination, when you are estimating the particular signal, when you are filtering out a particular signal, it acts like a noise canceller. Okay, so there is a derivation. I think everybody familiar with this, and I am not touching this. And these are the different applications. Okay, we'll use the adaptive filter for identification. We can use the adaptive filter for inverse system identification and prediction. And these are the three different algorithms in order to achieve that particular error signal is minimized. That means in order to get the optimum value, we can use these particular algorithms: LMS, RLS, Kalman filter. The origin for this particular LMS algorithm is the Wiener filter. So this is the open loop system where we can give the noise to the Wiener filter and signal to noise, and we can get the Wiener filter. And why we are not going for Wiener filter? When you see the error performance, the optimum value of the Wiener filter is equal to R inverse into P, where R is the autocorrelation matrix and P is the cross correlation matrix. So R inverse P means it contains the matrices. That's why in order to calculate the optimum values, we need to deal with the matrices. So this particular matrices, it is a complex algorithms when as the sample size increases. So that's why in order to avoid this particular complexity, people go for LMS algorithm. This particular LMS algorithm, with the help of steep descent algorithm, without having that particular matrices, we can process. This is the simple algorithm. We can compute the filter output, then compute the filter estimate. We need to update the next filter weights, and then we can do like this. Okay, but still in the LMS algorithm, there are certain limitations, effect of non-stationary, like that. Okay, afterwards, we can go for, in order to increase the convergence, we can go for the recursive least square algorithm. This is also by using the matrix lemma formula we can use. And now coming to the optimum is over. For the optimum, we are using the Wiener filter and other algorithms. There is one more optimum filter which can be used as the optimum as well as the optimal filter, that is called the Kalman filter. You can see. So this Kalman filter, which is an optimal recursive data processing algorithm. Okay, so optimal means here you can ensure the usage of all the available data, system and measurement device dynamics, statistical description of the noise, and initial condition of interested variable. Suppose, okay, for example, in order to determine the velocity of an aircraft, one could use Doppler radar, the velocity indications of inertial navigation system, and third one is the pilot and static pressure. From these three approaches, we can determine the velocity of aircraft. So then now coming to, rather ignoring all these particular outputs, Kalman filter could be built to combine all this data and knowledge of the various systems dynamics to generate the overall best estimate of the velocity. So the optimum means here the error will be minimized with the help of one particular algorithm. But optimal means here we will use the other approaches without discouraging any one approach. We can use their advantage and we will try to find out. Okay, so the Kalman filter is first one is the optimal, the second one is the recursive. Recursive is actually instead of using the all previous data, current data we can use. Okay, so with the help of that, if you see here, first measurement, we can compute the estimate m1 cap equal to z1, second measurement, third measurement. So you suppose if you take in the estimate m1 cap equal to z1, you can discard z1. Second measurement, you can get m1 cap by 2 plus z2 by 2. So store m2 cap and discard z2 and m1. Third measurement, you can store m3 cap and discard z3 and m2 cap. That means at each stage, the previous data we are eliminating. So that's why Kalman filter is an optimal filter, a recursive, and a data processing algorithm. If you see this particular thing, here the Kalman filter, we can take all these particular the different measuring devices and we can take their observed measurements. From these particular measurements, we can use the Kalman filter in order to get the optimal estimate of the system state. This is called the Kalman filter. I hope that. And the third one is adaptive filter, as you said. When there is a worst case, the signal or noise is superimposing. In such case, we can use the adaptive filter. And in the adaptive filter, we will use the optimum approach as well as the optimality also. Is it clear, sir?
Yes, sir. Thank you, sir. What we can shall we put it in this way? That is, optimal filter in general need not be recursive. For example, Wiener filter, it is non-recursive,
Yeah.
whereas adaptive filter, most of the cases it is recursive.
Yeah.
But Kalman filter, even though it is optimal, it is again
Yeah.
recursive in nature.
Correct. Yeah,
Thank you,
these
sir.
are the
Thank you, sir.
conclusions that we can arrive. Of course, this is a ocean actually, and there are a lot of mathematics which includes. Simply within 10 minutes, I have cleared, but there is a lot of depth in these particular concepts. Okay.
Thank you, sir. Thank you very much, sir.
Hope other people also have an idea. The question what the other professor asked is useful because most of the people have some particular ambiguity. So that's why I have cleared. So again, we can come back to the our other applications. So these are the advances: signal modeling, optimal filtering, spectral estimation, adaptive signal processing, multi-rate signal processing, speech processing, and these are the various applications. Okay, so this is for engineering applications, and this is one good example where in the dams, when the train goes, we can find out the with the help of AI and the expert system technology, we can find out where the fatigue crack growth occur. Real time we can connect a sensor and we can find out. And this is the applications in ATC centers, aircraft control system, and domain. And this is actually the signal processing application for expert domain for medical diagnostics, optimal signal processing, optical signal processing, and the biometric signal processing. We can use this particular thing for processing the bioelectrical signals. Okay. So that's all about the basic. These also for free vibration response and for computer networks. So this is about the general signal processing and applications. So quickly, 2-3 minutes I am giving time. Apart from the people who interacted, the new people, if you have any clarifications on this, I am giving the 3 to 5 minutes. You can share, and I will move to other topic. Meanwhile, you can have some water or something, and then I can switch over to other one.
Sir, one fundamental question, sir.
What is your name? What is your name?
Sir, I am Isekirajan, sir.
Sigirajan, from which place you are, ma?
I am from PhD College of Technology, Coimbatore, sir.
Yeah, good. Tell me.
Sir, shall we consider speech as a special case of audio, sir? Because there are two domains actually. Audio signal processing is there, speech signal processing is there. Actually, speech will come under the umbrella of audio or the reverse way, sir.
Yeah, but basically, speech signal is quasi-periodic signal.
Yes, sir.
Yeah, speech is a, suppose if I say shop, the speech contains the random in nature, periodic in nature, impulsive in nature. The signal, when you express that particular signal, when you plot in a waveform way, you can see these three domains. The signal is periodic in nature, random in nature, and impulsive in nature. That's why we can call the speech as a quasi-periodic signal. And rightly, as you said, that it's a audio. Hello?
Sir, audible, sir.
It's a audio. What you said? Audio.
Whether speech can be considered as a subset of audio signal processing.
Yeah,
Superset is audio.
Yeah, that is correct. That's why I am telling. It's the basic nature of a particular signal is a quasi-periodic signal. Okay, and it belongs to that particular the voice signal, and this voice signal comes under audio signal analysis. Okay.
Thank you, sir. Thank you very much.
Is it visible?
Yes, sir.
Okay. So coming to what is artificial intelligence. Okay. So artificial intelligence is a concerned with the design of intelligence in artificial device. So we need to embed the intelligence in an artificial intelligence. So these are the key two terms. One is called the intelligence. It's a computational part of the ability to achieve certain goals and gain rewards from that. And the artificial device, it's a computational device which performs the sequential calculations as per the intelligence. Okay, so artificial intelligence means we can come across these two particular topics. One is intelligence and artificial device. And the need for going for the artificial intelligence is, so day-to-day work is being increased. Okay, we need to automate the routine work. In order to automate the routine work, and we can see that these works are not protocol based, but are based on daily learning. So therefore, the normal sequential system design we cannot use. Okay, and the reason for going for the artificial intelligence is, you can see, in order to achieve the competitive edge, accessibility, fear of missing out, cost effectiveness, and future proof. For all these things, we can go for the AI. And this particular AI is interdisciplinary domain. Okay, so interdisciplinary of the artificial intelligence is which is having the creative thinking, explicit knowledge, language aptitude, numerical reasoning, verbal reasoning, working memory, critical thinking. All these particular interdisciplinary domains which involved in the artificial intelligence. And what are the different types of applications of AI? We can see that in the case of the surveillance, security, banking and finance, automobile, healthcare, then education, entertainment, social media. In all these cases, this particular AI is using nowadays. So most probably, I think you heard this particular parameter after the corona. 2 years back only, rapidly this particular AI and data science has increased tremendously with the help of the numerical applications of this particular AI. So coming to the hierarchy of this particular AI, basically we have artificial intelligence, which refers to simulation of human intelligence process by machines, including which includes learning, reasoning, self-correction. And the second one is the machine learning, which is an application of AI generating the systems that can learn and improve without being programmed. And deep learning is a subset of machine learning and artificial intelligence, and the term refers to particular approach used for creating and training neural networks that are considered highly promising decision making nodes. So these are the Venn diagram where you can come across artificial intelligence, machine learning, deep learning. These are the three cases. Coming to the classification of artificial intelligence, based on the capability, we have different category. Based on the functionality, we have different category. So based on the capability, there is a weak AI, general AI, another one is super AI. And coming to the based on the functionality, we have a reactive missions, limited memory, theory of mind, self-awareness. So narrow or weak AI is which can be used to perform a dedicated task with the intelligence. For example, playing chess is one example about weak AI, and general AI is intelligence which could perform any intellectual task with efficiency like a human being. The idea behind the general AI to make system which could be smarter and think like a human by its own. And super AI is the intelligence of the system. Missions could surpass the human intelligence. These are the three categories of the AI. Okay, narrow AI means dedicated to one particular task. General AI means perform like a human being, and third one is super AI means intelligent than human being. And coming to the based on the functionality, we have a reactive mission. Purely reactive missions are the most basic types of AI. Such AI systems do not store memories or past experiences for future actions. This is called the reactive mission. Limited memory missions, it can store past experience or some data. The theory of mind should understand the human emotions, people beliefs, and able to interact socially like humans. Self-awareness, these missions will be super intelligent and will have their own consistent, the what you can say, consistent consciousness, sentiments, and self-awareness. Okay, so these are the other category. When you come to design of AI system, okay, so any particular artificial intelligence system when you want to design, the first one is we need to get the data. So acquire the data to provide training, testing set for the mission. This is the first step. The second step is the data needs to be refined for normalization of data to remove the data redundancy. Okay, so here we can do that what you can say, clean, prepare, and manipulate the data. We can do first one is the data gathering, second one is the we can clean, prepare, and manipulate the data, and third one is we can train the model. The modeling of the system is done by training the mission with numerous number of training examples. And then fourth one is the modeled system is tested by evaluating the performance metrics based on error analysis. For this, some testing data is kept aside, and after testing we can improve that particular performance if any lacuna that occur. This is the actually the steps involved in the artificial intelligence. Any clarification here? Is it okay? Is it understand what is AI, and how do you design a particular AI system? What are the steps involved in a particular AI? Please respond.
Yes, sir.
Okay. And what are the different research areas in AI? You can see some of the research areas related to AI are expert system, neural network, robotics, fuzzy logic, natural language processing, signal processing, and useful full cases signal processing are speech and voice assistance, emotion recognition system, computer vision. So these are the applications where we can use it for predictive analysis, analytics, text to speech, image recognition. Okay, so in the language processing, what we will do is we'll do classification, translation, data extraction, then expert system planning and optimization, and robotics. In all these cases, we can use this particular the artificial intelligence. How do you use this particular AI? What is the relationship between signal processing and AI? Okay, and basically this particular signal processing involves the analysis, as we have seen, that interpretation and manipulation of the signals. So signals of interest include sound, images, biological signals, and radar signal. Since we'll have this particular analysis, interpretation, and manipulation, we can use this particular the signal processing and AI. So using the signal processing techniques and AI intelligence, lots of useful automated systems can be designed. Okay, and for computer vision, emotion recognition, and speech and voice recognition, we can use this particular thing. What are the design? How do you design a signal processing system with artificial intelligence? What are the steps involved? So now you please listen carefully. Any particular problem, because these days people are finally applying the AI for their particular research applications. Either it may be signal processing, or it may be image processing, or it may be what you can say data science application. And in all the particular application, people are using the AI. Then what are the steps involved in this particular thing? Okay, so first, from the input we need to process the signal, and we need to extract the feature extraction, then classification, then output. So the broadly this artificial intelligence consisting of the signal processing, machine learning, deep learning, all these particular steps. The first, input, signal processing, feature extraction, classification, output will have. And coming to the signal processing domain, in the case of signal processing domain, we have a input, signal processing, and in the case of deep learning, we have the feature extraction, classification. But in the case of machine learning, the separately we can do feature extraction, classification, and output separately will come. But in the case of deep learning, combinedly feature extraction and classification will perform in the deep learning. And this is the input and the signal processing. Okay, whatever we discussed now. How we can do the feature extraction, okay, by using the ML. Okay, so these are the feature extraction. Basically, the idea to go for a features is we can get the information about a particular the object or a particular scenario, and we will have different types of extraction approaches, a time domain approaches or the frequency domain approaches. And in the case of the machine learning or AI, we can use the filter methods, wrapper method, or the embedded methods. And this is actually the filter method, where we can take the set of all features and selecting the best set, and we can apply the learning algorithm, and we can perform. Okay, so filter methods are generally used as a pre-processing step, and the selection of features is independent of any machine learning algorithms. Okay, and we can store the selected features based on the scores in various statistical tests. So that's what in the sparsity also, we can create a dictionary for dimensionality reduction. Okay, so we can reduce the particular features. What we'll do is we will prepare a dictionary, and from that particular dictionary, I think we have the. I think one of my student is designing this particular dictionary by using the DFT method, DCT, and the discrete cosine transform. And there are different approaches are there. Omega K algorithms are there. We can use this particular dictionary, and whichever the features are having the desired information, those features only we can take, other features we can discard. Okay. Then wrapper method is we can combinedly generate the subset, and learning algorithm we can select the best set. And the embedded method is embedded methods combines the qualities of the filter and wrapper method, and which can implement the algorithms that have their own built-in feature selection approaches. So this is actually the classification, how we can do the classification. Various methods for classification is by using the classification trees, logistic regression, discriminant analysis, neural networks. Like this, we can use this particular the classification approach. But in the signal processing these days, people use the machine learning and deep learning methods. Okay, so that is about the artificial intelligence. So any clarification you please tell me, then we will move to the machine learning. So that is the basic idea about AI. So what are the steps involved in the AI? In the case of signal processing, how we can apply the artificial intelligence, and what are the steps involved in the artificial intelligence we have discussed. And in order to have the classification, now we will go for the, of course, there are methods are there, but people use the machine learning and deep learning. So in order to know the machine learning concept, so just I'm giving 2 minutes time. You can ask anything about AI, then we will switch over. Is it okay? Are you getting some idea about AI? Of course, within less time it's difficult, but are you getting some concept about AI? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now coming to the machine learning, it's a field of computer science which gives the computer ability to learn without being explicitly programmed. Okay, so use the data for answering the questions we need to train and predicting. Okay, see here the lot of what we can say we need to learn focuses the development of computer programs that can access the data and use it to learn for themselves. So this is actually the picture. It will indicate the self-learning about the machine learning. And there are three different types of machine learnings. One is supervised machine learning, another one is the unsupervised machine learning, third one is the reinforcement machine learning. So what is supervised learning refers to the class of system and algorithms that determine a predictive model using data points with known outcomes. Okay, so this particular supervised machine learning, which we can do the prediction of the continuous with the help of regression approach, like house price and the CO2 emission. Classification, we can classify the things like email spam or not given image cat or dog. And these are the different regression algorithms by using the linear regression, polynomial regression, logistic regression, ridge regression, lasso regression. And the classification algorithm, we can use the support vector mission, decision tree, neural network, k nearest neighbor, random forest. Of course, for classification, the traditional method is the principal component analysis, where in the case of principal component analysis, we can what we can say separate the things like how we have decompose the signal. We will decompose the parameter with the different types, like if you take an organization, their students and faculty is one particular domain, non-teaching staff is one particular domain. Like that, we can decompose, and decomposing their category and their wages, their responsibilities, their features, all those things we can separate with the help of the principal component analysis. Similarly, here also, in order to classify this, we have a different types of algorithms. And this is the regression example, how you can find out the price of a particular house. And this is the supervised learning principle. From the input data, we can process the data pre-processing, we can train and test, then model fit, we can predict and output. These are the steps involved in the supervised learning. Unsupervised learning is the training of machine using information that is neither classified nor labeled and allowing the algorithm to act on that information without guidance. So these are the types. We have a clustering and association. We can, in the clustering, we can make the groups. The data has not been labeled, classified, or categorized. And association allows to establish associations among the data objects inside the large databases. And this is the example about unsupervised learning. We have a input raw data, apple, banana, mango, and by interpreting the data, by applying the unsupervised learning, we can process and we can categorize. Here there are three different clusters are there: cluster 1, cluster 2, cluster 0. And from these particular clusters, we can train and test, and we can identify these type of the objects. And the reinforcement machine learning is, we have a positive and a negative domains. By using the Markov decision process and Q learning models, we can do it. And these are the terminology which we can use it in the unsupervised learning. And the third one is reinforcement. Here in the reinforcement, actually, by action, if you take the house element, then cat is sitting, we can take the action, walk, and if it walks, there is a reward. By taking that particular the action and reward direction, we can do it. And these are the some of the applications of machine learning. In the case of supervised learning, we can have the speech recognition, image recognition, medical diagnosis and classification, unsupervised learning, and then we have the reinforcement learning. These are the different types of applications. In the case of robotics, traffic light control, natural language processing, industry automation, and healthcare, we will use this particular machine learning. Okay. And coming to the third one is the deep learning. So why do you want to go for a deep learning when you have a machine learning? Okay. So deep learning is a subset of machine learning where AI networks, algorithms inspired by human brain, learn from larger amounts of data. So the basically the deep learning which will be used to solve complex problems even when data set is very diverse, unstructured, and interconnected. And it's a key technology behind. Okay. And basically we can have a, if you want to have a more accuracy, we can go for the hidden layer, and the number of pixels also more in the case of the deep learning. So in order to achieve the high resolution or high accuracy, we can use this particular deep learning. There are different types of deep learnings are there: feed forward neural network, then multi-layer perception, convolutional neural network. Mostly people use this convolutional neural network, recurrent neural network, and of course there are certain applications in the case of automatic speech recognition, image recognition, drug discovery, and taxonomy we can use. These are the applications: consumer relationship management, bioinformatics, military. Okay. So what are the steps involved in the deep learning in the case of the signal processing? So we have the create and access database, data resources, simulation and data labeling, and then pre-processing and transformation data, develop the predictive model, and then accelerate and deploy. So these are the four steps that we can come across in the case of the deep learning. So this is the deep learning versus machine learning. In the case of deep machine learning, separately we can perform the feature extraction, classification, and output. But in the deep learning, we can combine the feature extraction and classification. These the machine learning consists of thousands of data, outputs numerical value. See here, independently we can do the feature extraction and traditional ML algorithm. But in the case of deep learning, we can use the big data, millions of data points, and anything from numerical values to free from elements we can use. So how we can use this particular AI for image processing? Basically, image processing use of digital computer to process digital images through algorithm. Okay, so many big data will be there, the pixels. So 20 lakh features are present, which is very used to use them as features for deep learning network. So in order to reduce these dimensions, Image feature extraction is done using the image processing. These are the steps involved in image processing. We can take the grayscale conversion, edge detection, segmentation, feature extraction, learning system. Okay, so these are the steps involved in image processing. Okay, input image in RGB format is converted into grayscale. Then objects are detected by edge detection algorithm. Different objects based on the edges are segmented for further use. Then useful features are extracted, and then AI system is trained and tested using ML or deep learning. And another one is interesting one is the speech emotion recognition. So here in the emotions we can, whether it is a laughing, discussing, these things which we can find out with the help of this particular what you can say the AI. So I will try to show that particular emotions later. So the input and signal processing, feature extraction, classification, output, as I have shown in the case of signal processing, same thing here also. And here various signal processing techniques which are used for extracting the features. One is there are two features, acoustic features. Okay, linguistic features we can find out with the help of acoustic features which are extracted using triangular filter bands. These are also known as sectoral features, and linguistic features with the help of word embeddings and the speech embeddings. So like this, we can find out the acoustic features, linguistic features, and in the case of speech emotion recognition, we can use the deep learning neural network. Of course, V detection using in the AI. Okay, how we can V detection we can use it. Fisheye correction. Okay, we'll use the YOLO algorithm in the VA. These are the multispectral image, fisheye correction, YOLO algorithm. These actually the weed detection which we can use it. And autonomous drone navigation using reinforcement learning, okay, Q learning. These are the other applications. And radiology using AI, how we can use in the radiology, can take the input image, feature extraction, feature vectors by applying the machine learning, and the best classifier model, feature vectors we can calculate and we extract in the new image. So in radiology, people use this particular AI. Okay, so there is last application is there, computer vision application. With that I will try to close. So these are the machine learning and AI and its applications restricted to the image processing. And lastly I will give some particular light on computer vision. So up to now I'll give 5 minutes, you can ask me anything about these things: machine learning, the artificial intelligence, machine learning and deep learning and its applications. Last one, computer vision, I will try to show last. So anything, please interact. Of course, it's a new domain, but it is very useful. You can apply in your the sparsity while evaluating the features, feature extraction. That is when you are developing the dictionary, verbal and non-verbal dictionary. There we can come across the dimensional uh, reduction. We can use the
Sir, good morning, sir.
classification.
Hello.
Tell me. Ask ma. Hello.
Sir, good morning,
Yeah,
sir.
is there anyone who is
You
supposed to
AI
ask a
solution,
question?
sir.
Yeah, please, please.
There is a resound is coming.
Sir, I have one question. Sir, suppose that we have a signal, say some biomedical signal.
Introduce yourself. What is your name, ma?
Sir, Thomas Halder, sir.
Yeah, yeah. Okay.
So I'm from sir Kharagpur. So sir, actually Kharagpur, West Bengal. Sir, actually I want to know that sir, if we have some biomedical signal, and we also
Yeah.
have its time frequency representation as a image. Okay.
Okay.
So I want to classify both image and signal at the same time. So how can I do that?
You need to classify signal and image both at a time.
Yes, sir.
Okay,
Let's say
so
we have says a time domain feature as well as we have the time frequency domain feature
no,
also.
no, because one thing, Mr. Thomas Alwal, combinedly we cannot determine the time domain or a frequency domain. Okay, there are independent the time domain feature extraction approaches, independent the frequency domain extraction features. But one thing you can do that you can by applying the wavelet transforms we can you can separate there actually with the help of the approximate coefficients or detailed coefficients, like that we can separate time domain features or frequency domain features. But the extracting the features exclusively separate, not combinedly, we cannot get. That is one thing. Second thing, in order to determine the features in time domain extraction approaches. Suppose when you take the speech signal, okay, so then I'm taking that speech or what you are asking the image. Okay, so for time domain features, I can use different calculating the energy. Even you can use it in the image also, and magnitude of the energy. Okay, so with the help of those things, I can find out the time domain feature. But when it comes to the frequency domain, I can use the fast Fourier transform or discrete Fourier transform. I can use and I can separately find out the frequency, the feature. But combinedly, as of now, up to my knowledge, I don't have much idea about that. We did actually separately only. Still, if it is there, I'll inform. You can mail me. Okay, Thomas?
Sure, sir. Thank you, sir.
So, are you following? You got any idea? Okay.
Sir, that wavelet transform have the both some multiscale and dilation and translation what I learned in previous lectures.
Yeah, yeah.
So sir, but my sir question was that if I want to say we have the speech as a time domain, and the second thing is that we do the strum or the time frequency.
Yeah, I
Feature.
understood. I understood your question. You are asking at both the same time, you want the time domain as well as frequency domain. Is it right?
Time frequency domain, sir. That feature.
Time frequency. But there is one application in the case of the emotion recognition. We
Yes, sir.
did the voice as well as image we have taken.
Yes,
But
sir. That is my
what we
answer.
did is we have taken the two parts will be there. Voice we have voice separately we applied to the voice recognizing system, and the image we have taken the image frame by frame and the image feature extraction. That means at the input side we will divide this particular the two parts. One is the voice, other one is the image. There only at the before pre-processing itself, we are dividing these two parts, and separately we can apply different extraction technique approaches. And for speech, voice signal, we have a separate pre-processing approach, and then we have a pre-emphasis approach. After pre-emphasis, we will do the filtering, and then after filtering, we can go for the other methods. And similarly, in the image, after extracting the image frame by frame, we can go for the image segmentation. Then after the segmentation, we can take the threshold, and after threshold, we can enhance that particular image and we can process. So like that, two different things which we will divide at the type of input only. Okay.
Yes, sir. So, sir, as you said that, sir, there is a software called Leap to Walk. So they are actually lip movement actually showing the predicted speech. So
Okay.
sir, so this kind of application is done. But sir, the thing is that when we do the EEG, say we have the EEG and the time frequency domain image we also have, but we cannot combine it. So how we can combine? So that's we are struggling at.
Yeah, yeah. Okay, you can send your problem to my
Yes,
mail ID or your coordinator, Dr. Kishore. So he will forward and then I will try to send reply. Okay.
sure, sir. Sure, sir.
Yeah,
And
good.
sir,
Good, Thomas.
another thing is that to show application drone based uh, uh, just one meter drone uh, showing at that time. So I could not follow at first.
I'm not able
Hello.
to hear clearly. There is a resound is coming.
Oh, sir. Okay, sir. Sir, I want to see. I want to, sir, follow that the drone images what you put on the slide, sir. The quick moving, sir. I could not follow the thing, sir. Can you explain that the how the drone
Yeah, yeah,
images you are segmenting
yeah, yeah.
or? Yes, sir. That one, sir.
This one. This is autonomous drone navigation. This is by using the reinforcement learning approach. By
Yes, sir.
using the queuing algorithm, we can, of course, this is the queue learning approach. You need to have some idea about this particular queue table data structure, and we need to choose an action, and we have to perform that particular action, measure the reward, and update the queue table. This is actually in the case of reinforcement method. For every action, there is a reward will be there. Okay.
Yes, sir.
So based on that particular technique, we are using this particular drone navigation, a drone navigation in closed environment with discrete state space. Okay, here you can see the red circle is the drone current state. The green circle are the options that the drone can choose in the next iteration, and the goal is marked by a red flag. So this we need to identify. Like the checker game type, we can the optimal path how we can arrive this particular the what you can say flag position. So in that particular cases, by using the drone navigation to determine the different positions, different paths, we can use it autonomous drone with the help of the reinforcement method. So this is actually you should have some idea about this particular thing. You can see that for every state and there is action, and for every action there is a reward. By using this particular drone mechanism, you should have some particular idea. Okay,
Yes, sir.
yeah, just for the application wise, I have shown these things.
Thank
Okay.
you, sir. Thank you, sir. Thank you so
Now
much.
coming to the computer vision, just quickly, I can show the computer vision application. Then we can stop. So basically, computer vision is the processing of digital images. We need to understand the images and videos using the computers. So basically, this computer vision involves the we need to acquire, processing, analyzing, and understanding the digital images, and we need to extract the data from the real world to produce the information. This is the basic concept about the computer vision. What are the and the subdomains is object recognition, video tracking, motion estimation, and we can use this in medicine, navigation, object modeling. Okay, so simply we can say that it works the device using a camera to take pictures or videos, then perform analysis. Okay, the goal of the computer vision is to understand these particular information, and how we can use this particular the machine learning. These are the steps I will try to show. We can use there are number of the computer vision problems, image classification with localization, object segmentation, image style transfer. All these things will come into this, and this is the computer vision and machine learning. We need to train and test. Okay, see, image features we can take, we can develop the learned model prediction. Okay, and in the training we can take the image features, we can train, and we can determine whether it is a dog or a cat or a raccoon. So in this case we can use the machine learning, and similarly for the other particular applications can use the vision based self driven car. So we can take the different image sequences, applying the machine learning and computer vision, and four actions of the car: left, right, accelerate, brake. We can do with the help of the vision-based self-driven car. So features determine what action take next. This is the block diagram. We can capture the image, basic image processing method, and we can use the thresholding technique, global thresholding, local thresholding, and image segmentation. Then afterwards feature extraction and selection. Then we can have a classification. These are the steps involved in the case of computer vision with the help of the machine learning. So this is the dimensions of a board sign, traffic light we can determine. And in order to find out the sign, some silent features we need to calculate. The features pertaining to the particular the vehicle approach and how long it is there. Based on that, we can find out feature identification. Object detection and face detection we can use to identify the particular facial feature, and we can determine the eigenfaces. This is actually, you can see, search for faces, pixel pattern, we can extract the features. After extracting the feature vectors, we need to classify. The classification, that is it. And detection of elements based on machine learning, you can classify robotics, material inspection, object recognition, pattern recognition, we can use robo vision system. So these are the applications of computer vision. So that's all about the computer vision application. So that's all about this particular topic. So just I have given the different domains about this particular the signal processing applications, artificial intelligence, machine learning, deep learning, and where we can come across these particular applications. Okay, so now 5 minutes time I can give it to you, 5 to 10 minutes exclusively interaction session. So who are working in the different areas, you can share your experience, and if you have any clarification, then you can ask. Okay, I hope that you
Sir,
can
good
have
morning, sir.
yeah. Okay.
Sir. My name is Lokesh. I am working in the field of array signal processing, sir.
Okay.
Sir, exclusively I am working on the problem of DO estimation.
What now?
DO estimation, sir. DO, direction of arrival estimation.
Okay.
DO estimation.
Okay. Okay.
Sir, I need to search for 180 angles, sir. Minus 90 degrees to plus 90 degrees, sir.
Okay.
So I'm applying deep learning algorithm, sir. ANN network actually.
Okay.
So each, sir, I have taken 10 sensors.
Okay.
So these 10 sensors corresponds to one output. Each angle corresponds to one output, sir. Different measurements. These 10 different measurements. Sir, can I apply CNN algorithm for this measurement, sir?
Yes, CNN we can use, but you need to select the
Sir,
nodes actually. Okay.
sir, sir, CNN is exclusively used for images, no, sir. Generally, ANN
Yes.
is used for a tabular form. ANN is tabular form, so I have used and generated, sir.
Okay. Okay.
So can I use CNN to generate this kind of output?
But
Then,
normally for time of arrival estimation problem, actually in the exactly, I don't have much idea about that because we applied actually the till now the image processing applications, biomedical, speech processing we applied. Okay,
okay, okay,
but the estimation problems mm, as such we have not come across this
okay,
deep neural network. Okay,
okay, okay, sir.
exclusively for that particular application. Okay.
Sir, sir, or can I, sir, we have to classify these 180 angles.
Now,
Is there any better?
for classification, of course, if you have clarity about what is the input data, how you will take the input data,
Okay,
and for classification of these angles, so which type of angles you need to classify. Okay,
okay,
so if you are able to identify that particular input and input data, so
okay,
then there is a mechanism, but again you need to search the classification of these particular angles with the help of the machine learning approach. Like as I told you, for classification, either you can do the support vector mission approach or some particular the constructing a diffusion matrix. Okay, sorry, confusion matrix.
okay.
Okay, so KNN nearest neighborhood approach. So most probably KNN and support vector mission people use now. Okay.
Sir, 180 angles are there, no, sir? Which
Yeah, yeah.
will be best, sir? Which will be best one, sir, among these classification? Big data will be there, no, sir? 180 angles, very big data will be there. Which one of will be best, sir? Support vector machine or KNN?
I feel support vector mission only you have to use now.
Okay, sir. Okay. Thank you very much, sir.
Okay.
Sir, is there any
You are
possibility
working
of
with
using?
you are working in Dr. Kishore sir, no?
Yes, sir. Yes, sir.
Yeah, no, I think Kishore sir he is having idea, but you can discuss with him. Okay,
Okay,
in
okay,
future
sir.
also
Okay.
we can discuss. Any other person?
Uh, sir, is there?
Not
No, sir.
you. Any
No.
other faculty from other parts of the place? Lokesh, you are here only, no problem. At any time while going Hyderabad, you can come Warangal, you can discuss. Okay,
Okay, sir. Okay, sir.
no
Thank
problem.
you very much, sir. Thank
Mm.
you very much.
Yeah, now the session is open for the participants to ask questions. Please make use of this session.
Because I don't know I can justify within 1.5 hours or 2 hours. Whatever the areas that I discussed, they are the vast areas, of course. But the people nowadays, people are using these machine learning concepts in their particular, most probably after completion of their research work in their particular the work. The final chapter, people are applying this particular machine learning, and they are comparing these and the performance analysis they are doing, so that it's like a flavor type they are adding, and they are testing their particular while validating their particular results during these days. So for that case, definitely this machine learning concept is useful. One of my of course faculty or a student, he is working in sparsity for speech enhancement. We are working, he is developing a dictionary for the dimensional reduction only. Okay, he is taking I think 2 3 papers right now. I don't have that particular material, but otherwise I can share next time.
Yeah, any questions, please?
What Tamesh Haldar. Something he is.
Sir, the dictionary contains the Fourier basis or random matrices
What
like
ma?
Gaussian. Sir, the dictionary in compressive sensing actually have the either Fourier transform or the random matrices from the Gaussian mixture. So not
No, he did
in the
actually.
Van der
He did Fourier approach, discrete Fourier transform, DCT, DST. He applied and he developed combination of DVFT, DECT also he has taken. Okay, 4-year based only he did actually.
Thank you, sir.
Okay, man.
Fine. If the participants don't have any queries, then I would like to conclude today's session with your permission, sir. So if anyone has any queries, you can ask. Otherwise, I would like to conclude today's session. I would like to thank my professor, Dr. T. Kishore Kumar, sir, for accepting the invitation and delivering a 2 hours long duration talk, sir. Thank you so much. In spite of your busy schedule, you have accepted our invitation and delivered a very good expert lecture, sir. Thank you so much, sir. I hope your interaction with MIT Andhra Pradesh Department of EC will continue even in the future also, sir. Thank you so much, sir.
Thank you, Kishore.
Thank you, sir. Thank you so much.
So I'd like to once again thank you, Dr. Kishore. He is very, very honest. In fact, faculty, earlier day student, till today, for synopsis, he'll remember, I think June 8th, and for May 11th, for PhD submission, I think he has completed 2011 or 12, Kishore?
Submission is done on 2012, sir.
12,
Yeah.
June
13th
8th.
it has.
June
Yes, sir.
8th.
Yes.
May 11th is Viva.
Yes.
So, but till today, he is in touch and we are working both jointly. I think, in fact, he forgotten that in one DRDO project also, for my first DRDO project, he is also one of the co-investigator. Now, I think, in fact, he got the Korean postdoc. He has not gone to that particular Korea, but he stayed here only, okay, for personal reason. So very, very good. And I hope that I want to see him a good position. And once again, thank you for giving this opportunity, Dr. Kishore, and for the entire department of NIT AP.
Thank you so much, sir. Thank you
Further,
so much.
if you have any queries or any clarifications, you can contact Dr. Kishore and he will pass on to me and we can have the interaction. Thank you very much.
Sure, sir. Thank you so much, sir.